Hi everyone, welcome back. So today I will explain you how to build a linear model in machine learning. So in the simple linear model, which handles the simple linear regression, where you have the equation like y is equals to mx plus c, and this is where y is your dependent and x is the independent. Okay. Now, initially, if I take consider the first step includes extract data. After that, I will go to exploratory data analysis. I have to explain what the data contains. EDA. And the third step, after explanatory data, explaining the data content, I will build then feature e- extraction. Fourth step will be me model building. After building the model, I have to predict, means testing. And final step, visualize the results. So this is what the steps that comes under simple linear regression. In the extract data, what I will do, I will import the pandas package. I will read the data from CSV file or Excel file. In the explanatory data analysis, I will get the information about the data of the CSV file, whether it contains the null values or not, and information about each column and its respective data types. After that, I will do feature extraction, which comes where I will take the x and y, which is nothing but independent and dependent variables. I will separate those features. In the model building, after extracting, I will build a model based on the features that I have. Say, if I have the 100% data, out of that, I will give 70% of the data to the training and 30% of the data to the testing. After building a model, I have to check whether the model is exactly fitted or not, or performing well or not. For that, after building a model, I have to predict. I will do that step here. After predicting, I have to visualize the data. We are between the raw data and final results. Means after predicting what is the expected output, what was the actual output. That the step that I will do here. So let's do this in the next video. I will explain each and everything. Hi everyone. So in the last video I have explained the what are the steps to be carried. So let's start with the extract data code. I will import pandas as pd, and after that I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in I will take data is equals to pd dot read underscore csv. Here I will pass the value where I am ready with this. Control C and paste it here. Make sure that your path is within the double slash, which considered as the escape character. So it will consider the first slash. Let's check whether it is data read or not. Data dot head. If I run this, select the kernel, so it will be going to execute, and I will get the first five rows. Good. So I am having the years of experience and salary, and I will consider the salary as my dependent variable. Okay. In the exploratory data analysis, I will check whether it contains any null values or not. Data dot is null dot sum. So there is no null values, and I will get information about the data frame information info. Good. So it is both are in the float type. Well and good. If it is an object, then it should be the error because it contains null values. Describe. I will check the information about everything. So I have the count, median, standard deviation, mean value, and 25% of total years of experience, 50 and 75, and maximum value. So there is no issues because no null values are there. Now I will go for the feature extraction. So for feature extraction, I will take x and y. In the data.ilog, I will take -1 means except the final one. I will consider everything, or else you can consider like this also. Copy this years of experience and give data within the bracket double quotes column name. You can do that also. Data dot ilog of column comma -1, which means the last column, or else I can write anything is okay. Data, anything can be work. So X will store the years of experience, Y will store salary. Let's check what will happen. First run this, executed, code, print X. Well and good. So years of experience I got. Say next one is print Y. This is my salary. Years of experience, and this is my salary. Now I will the build a model. In the build a model, the step one comes split. Step one 4.1 split data. From to split the data, I will take from sklearn dot model selection import train test split. So x train, y train, x test and y test will come from this method. Means this method will return four values. Those are x train, x test, y train, y test. and here I will pass x and y, which takes only 70% of the data. Test size 0.3 with random state equals to 42 or any number. You can also give any number. Print. Let's check the size shape of the X train shape. X underscore train dot shape. In the same way for the Y train also. For the test, Y test, X test. This will be Y test. Let's run. So here if you see X train and Y train, X train, Y train, I have split it. Next step will be 4.2 train the model. To train the model from sklearn dot linear model import linear regression. Now model is equals to, I will take the reference of the object model. Now I will fit model dot fit x train comma y train. Here I am training the 70% of data. How? I have given entire data set where I am saying that I will keep 30% of the data for the testing and remaining will be 70%. So those 70% is my training data, which is fitted to this linear model. Executed, done. After that, I have to predict the model. What is the accuracy? So testing accuracy is equals to model dot score x test comma y test. Print test accuracy, testing accuracy. Oh, nice. So model is predicting around 94%. 94%. We can find the some more metrics, evaluation metrics. How can you do that? From sklearn dot metrics import mean absolute error, mean squared error, and I will take import numpy as well for the simple mathematical calculations. Numpy as alias numpy np. So I will take train accuracy. You can also find the training accuracy as well. Train accuracy equals to model dot score x train comma y train. Print train accuracy. I think we can also make this as testing accuracy. This is my training accuracy, and I will add mean absolute error (MEAE) variable, and here I will take mean absolute error for x y test. Sorry, for the y test, comma model dot predict x test. So I'm comparing with the y test with the predicting values. So this is my raw, this is my predicted values. In the same way, print MAE. I will copy this step. Mean squared error MSC. Mean mean squared error MSC. Mean absolute error MEAE. And final one, root mean square error. Root mean square error is nothing but the square root of mean squared error. So from np dot sqrt, I will pass MSC directory. So I will print root mean squared error as RMSC. Got it? So I will run this. Let's see. Nice. So training accuracy is my 95% and testing accuracy is also a 94%. So it is good. Now I will visualize the results. To visualize the results, I have to plot. How? I will import the package, import matplot lib dot pipe plot alias as plt. I will plot plt dot plot x test comma y test. This is my raw, means raw data. So this is my test data. So I will label it label equals to testing data, or else I can say tested data, test data. I will plot in the same window with x test and model dot predict x test, which is nothing but y, y prediction. I will label it with predict values. This will predict it. So as I have given the label, I have to display it with legend function, and I will show the plot dot show. If I run this, oh, this is how the results came. So predicted value and testing test data. So it is uneven because the salary is fluctuation. So I will. How can I do that? Take this as scatter. Okay, instead of plot. If I run this again, cool. So I found the best fit tag, and I think I have to arrange set the color. C is equals to color is equals to red, and here also color is equals to red and green. If I run this, this is my best fit rate for the prediction predicted values. I can add the titles plt dot title simple linear regression plt dot x label salaries plt dot y label years of experience. Okay, so in the x-axis I have the okay years of salary. Okay, it should be swap. I will simply y do this as y label. This will be x label. That's it. Done. Okay, and this is how we can build an simple linear regression. In the recap, first I have extract what is simple linear. Linear is nothing but y equals to mx plus c, and this is the simple one equation, simple linear equation with one independent variable. Simple linear regression with, which has only one independent variable, okay, and one dependent variable only. That's it. And to build this model, first I have to extract the data. I have extracted the data. After extracting data, I have explained the data, whether it contains null values or not. If not, then what is the data information and describe the data. I have described. After that, I have done the feature extraction. I have saved the independent variable in X and dependent variable as Y, and I have executed and checked whether it is okay or not. And after that, I have built a model. First, I have split the data in two parts. 30% of the data will go for the training set and 30% of the data to the testing set. And I have taken the linear regression for train the model for with the training set. So this is my 70% of data is being trained to this linear model. After that, I have predicted with the testing data, which is the 30% of data, which gives me 94%. After that, evaluation metrics for a training set and mean absolute error, squared error, and root mean square. This is the values, and this is my visualizing data. This is my data that I have got. So this is my best fit train. So it gives me the linearity. How much fit has been done as per the testing data. This is my simple linear regression. Any doubts? Any explanation you need? Let me know.